All right, folks, apologies for the delay getting started today. I had a technical issue with my streaming software that really set me back. Obviously, I've been troubleshooting it for close to an hour now, where it wasn't presenting, it wasn't for some reason capturing one of my text editor, so I wouldn't have been able to present. So um, after much ado, things appear to be working now. I do have a new microphone here. It looks like it's peaking a little bit. I'm going to turn down the gain. Check, 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 check. Excuse me. Testing, testing. Check, check, check. Let me know in the comments in the thread how the audio is, if it's peaking, if it's too loud, or if it's too quiet. Hopefully that's okay, though. Should do a little bit more. Okay, good. All right. So we just started a new premium prep cohort, and I thought I'm gonna just sign into that cohort and learn, and we'll start going through the material in there. So let's see, let's come back here. All right, so we're just gonna start, I'm gonna jump ahead a little bit, and I'm gonna kind of push us forward until we get into some code. We're gonna just be exploring the introduction to Python section. If you have any questions, feel free to bring them in. Put them in the thread. You don't need to, they don't need to be on the topic that I'm covering now. Study Hall, if you're new to Study Hall is mostly about providing a place for you to bring your own questions, and you're welcome to help each other solve those questions as I go through them, but also I'll go through them, and yeah, people can see the solutions that I make. If you have any code that you want me to troubleshoot, you can bring that as well. So the questions that you bring to the table don't have to be on the, like, pertain necessarily to the exact material that I'm covering. Yeah, so any Python question will do, and we can go through it on stream together. Great. Look forward to your participation. All right, so we're gonna start in this Python basics section. So let's go there. All right. So let's see. Actually, let's move forward from this. This is just gonna kind of go over some conceptual stuff, and you'll have an opportunity to like put in a sentence that's just a brief description, so you can't really get these questions wrong, but we can go through the unit overview and everything. So by the end of this unit, we want you to have a working knowledge of the fundamentals of Python and be able to apply them to the completion of simple tasks, such as calculation and storage of numbers into variables. So just basic sort of using Python as a calculator and being able to save results into variables. So if I add 10 plus 20, I'm going to save the result, which is going to be 30. I can save that into a variable and use that later. Obviously, that's useful for, you know, more complicated things than a simple problem like that, but we'll get into that. The first thing you want to do in this unit is explore basic data types. So we're going to talk about the different ways that Python represents information, different kinds of information, different types of data internally, right? I.e. data types. And then next you'll work with concepts regarding incrementation and mutability of data types. These are going to be, well, you know, I want to put particular emphasis on incrementation. Being able to, well, incrementation and iteration, being able to iterate through some process repeatedly until you accomplish some task. So these concepts will be illustrated using the built-in functions type and ID. Other Python fundamentals such as printing, indentation, and comments are also briefly discussed. Unit videos. So the videos in this playlist are spread throughout the lessons in this unit. We will include them here in case you want to watch them in one go. All right, sorry, I don't need to go through this. I'm like, wait, why am I reading this? All right, so this video will go over certain concepts, and I'll ask you to go through them here. So I think I'll save this for later, but in general terms, we can just say that a function is, in Python, a function is a way of encapsulating some process. So you write a process once and you implement that process with certain inputs that change the output. And yeah, go from there. We'll be working with functions a lot. On to common data types. Okay. Now we can start getting into stuff. Cool. Common data types. So by the end of this lesson, we want you to be able to describe the basic properties of Python's 3 most common built-in types. Use the type function, and I would also say use the print function to observe the type of a given object. Okay, so let's just look at that real quick. I wonder what types it's going to, integers, floating point numbers, and booleans. Okay, cool. So first of all, so this lesson is going to cover integers, booleans, and floating point numbers. So integers and floating point numbers are what you would just think of as numbers in your day-to-day life, but they're broken into 2 categories, and we'll get into the reasons for that in a second here. Booleans are easy. Booleans just have a value of true or false. So let's play around with some integers since it's a nice, easy landing point. So an integer is what you think it is. It's just a whole number. It can be positive or negative. So 4 is an integer, 0 is an integer, 1 is an integer, negative 25 is an integer, 37 is an integer, right? So this is Python's integer type. As I'm working, you're going to see me use this function print, P-R-I-N-T. Print takes parentheses immediately after it. So you'll say print and then parentheses. And then inside of the parentheses denote what the inputs are to this function called print. So I have this function that's built into Python called print, and I have to give it an input, which is, it's going to be the thing that I want to print, right? So if I have the number 4 plus the number 5, this will evaluate to 9, because 4 plus 5 is 9, and then this is going to print it out to the console down here. So every time I save this document, it's going to run the code. Cool. Oops. All right, and we get 9, right? So that's going to print out the value 9. So important to realize that because I'm going to be using print a lot. It's a simple tool. It's it's the first tool that I would teach somebody, and it's also one of the most useful tools you have. So just because perhaps you're a beginner to Python, if that's the case, don't underestimate print just because it's the first thing you learn. It's one of the most useful tools to have in your arsenal or in your toolbox. Let's say that. All right, so that's just going to show me whatever I pass to it. So if I wanted to print 4, I could do that. And it'll print 4. Cool. So I just showed an example of addition, 4 plus 5. This is just simple addition. It works like you think it's going to work. Python obviously can do other kinds of math other than just addition. We can do 4 minus 5, 4 times 5, 4 divided by 5. Things get a little funky with division because there are 3 operators that are related to division. So there are these 3. Let's just look at these 4 basic operators for now, right? Addition, subtraction, multiplication, and division. Multiplication uses the star operator that for me, and I think for most people, it's going to be shift 8. It'll be that asterisk operator. So you can see these give the answers that we'd expect. Notice this last one, 4 divided by 5, is going to give us a number 0.8. And that number is actually a floating point number, which we're also going to talk about here in a second. Cool. It looks like we got a question in Slack. Somebody's saying, hi, new to the DSI prep. Notice there are many study hall videos on YouTube. Is there a good place to start that aligns with the prep materials so I can just dive right in? Thanks. I'm trying to make today's video that good place to start. In general, we persist the videos for study halls, not necessarily to keep a backlog of things that you should go through, but just in case you come to a study hall and you want to, like, you know, maybe I cover a concept and a little while later you're like, oh, Clark went over this, you know, you're working on something and you're like, Clark went over this concept in a previous study hall that I saw. And for people who may not be able to make it to study halls. So they're less of like a backlog of materials that you should like go through all of them, because there's going to be a lot of them. And since we started a new prep, I'm trying to make today's video the sort of starting place for the new round of premium prep. So hopefully that helps. Let me know if that helps. I know it looks like a couple of people are into this question. Give me a thumbs up in chat if that helps, or if you have other questions, feel free to ask. Okay, cool. Yeah, you're welcome. Good. Okay, we got another one here. Could I go over ways to remove from / add to each data type? I'm always mixing up which method goes with which data type. That's a good question. We got another one. Did I go backwards in the curriculum? Yeah, we're starting over at the near the beginning. I don't mind taking questions from anywhere in the curriculum, but in terms of the material that I'm covering, I'm starting at the beginning today. But like I said, study hall is about taking questions. So we have a question here from somebody wanting to go over removing and adding elements to each type. So this gets into, we're going to kind of change gears a little bit to talk about this question. So we're going to preview some other types that have the ability to like grow and expand, right? So numbers, just for contrast here, I'm just looking at integers here. We look at this down here. This is a floating point number. A floating point number, if you're not familiar, is a number that has what we call a floating point in like the words have just left me. In normal day-to-day language, we would just call this a decimal number. So when you hear floating point, no, that's a fancy way of saying a decimal number. So all of these, any kind of integer or floating point number is going to be just, you know, fixed at the value that it is, right? Like you can't alter what 4 is, right? You can say 5 instead of 4. You can specify some other number, but you can't change what it is to be the number 4, right? Same with the number 0.8, right? those are fixed quanta, right? And that's it, right? But there are other data types. Python has a lot of different types for representing information in different ways. Obviously, numbers are for representing numeric data and performing mathematical operations, which we'll touch on here in a minute. But there are also, sometimes you want to have a collection of different other types, right? So there are certain types that sort of act as collections of things, right? So let's look at all of those, at least all of the basic ones that you encounter frequently. So there's strings. So this is a kind of collection. So strings represent textual information. So they represent textual information. So just text, right? Let's just call that text information. Then there's lists. Let's just go with lists. Lists are, well, they're what you think they are. They're a list. They are a collection of arbitrary things. So right, so we could have, let's just call this collection. Well, COLECTION. Okay, there you go. Collection of objects. Collection of objects. They can be mixed and matched. When I say objects, that's sort of another word to help us talk about types in this particular instance, right? So I can have a list with strings and integers and other lists in it, and it's just a way of making a collection of things. There's also dictionaries, which are similar to lists, except lists have an order that's baked into them that's important. So all of the elements in a list are implicitly numbered, right? So the first element is 0, and the last element is whatever the, however many elements are in the list minus 1, right? So if you have 10 elements in the list, the numbers that correspond with each element in the list are called indices. So you would have 0 as the first element, and then list index 9 will be the 10th element. So it's a little funky, but and we'll be covering these concepts shortly. If you're a little new, we'll work up to this, and no worries. You'll get to that point faster than you think you will. Okay, and then dictionaries, like I said, they're like lists, except instead of having numbered indices, they have explicitly named keys. Often the keys are other data types like strings. And let's just say, just for the sake of simplicity, lists and dictionaries are both collections of objects. We have another type that's sort of in between a list and a string. I think about it that way. It sort of has similarities to both. Really, you can just think about it as a sort of a simpler list. It's called a tuple. It's very much like a list. The difference is that a list, so if you imagine your list exists in your program's memory, and it can manipulate that memory, it can grow and change in size, it can pull out one object and put in another, it can add things to the end or the beginning of the list or in the middle, it can remove elements so it can shrink in size. There are various things that you can do and change that list that's in your program's memory. Those particular things aren't available for a tuple, so tuple is more useful for when you have like a short collection of things and you don't need to alter it, but you need it to be predictably sized, right? You need that tuple to have a fixed size for some other reason, right? So you don't have quite the flexibility of altering a tuple like you do with a list, but what you lose in flexibility, you gain in predictability, and sometimes that predictability is favorable to the sort of flexibility. So tuple is a collection of objects. Again, so what I just described between the tuple, where it's predictable but not flexible, is that flexibility, that ability to change, is called mutability. The root of that word is mutation. So a list can be mutated, whereas a tuple cannot be mutated. So we call tuples immutable. Immutable. Excuse me. I'm looking at that and I don't have confidence that that's the way it's spelled. Apologies. I feel like I need to disclaim that, full disclosure, I'm dyslexic and the spelling is not my strong suit. But at any rate, we consider tuples immutable and we consider lists to be mutable. So lists can change and grow and shrink in size, whereas tuples are just fixed, right? Okay, so these are our collection types. And the question on the table is, what do we do? How do we add and remove things from each type? I'm going to show you a system that you can use to manipulate all of these types. So if you recall, and this is a little advanced from the sort of beginning materials, but if you recall learning about lists and learning about slicing and indexing, let's just have a list. We'll some list here, and we'll just put some objects in it, right? I can use slicing and indexing to manipulate lists. The same thing is going to be true with tuples. Let's make a tup as well. And the way you make a tup is you just put parentheses instead of square brackets. And let's do the same thing with a string. I'm just going to do that for string. And what's a good string? Let's say we'll do that. Oh, they're like all the same length. That's nice. Okay, so so let's say I want to add something on to the end of each of these. Well, with lists, there's a built-in tool for lists called append. I can say list.append, and then whatever the thing is I want to add. This is a list of numbers, but let's say I want to add a string that just says, hey, let's just print the list. So this is probably the most common thing. You have a collection of objects and you want to add something to it, which is a very simple and common thing to want to do. Having a list that you can mutate is really useful. So append mutates the list by adding a value to it. So notice I call list.append. I pass the thing to append that I want to add into the list, and then I print it off, and that's going to show me. Cool. All right. So that's one example, and I think if you've gone through the material on lists, that's probably an example that you're familiar with. But I want to show you sort of a fallback. There's sort of an easy way to do manipulation of all of these with indexing. So I'm going to comment that out for now. So let's say I want to add something on, because I don't have like an append method for tuples, right? But you can kind of fudge it if you want. So I can say tup plus equals, and then I can make another tup with the thing that I want to add. Let's say I want to add hi. We want to have a tuple with a single element in it like this. Oops, I'm printing out the list. I'm like, wait, what happened? I was printing out the list, not the tup. Cool. Whoops. Let's do list here and st here. So I'll print out the list and the tup and the string. And interestingly, this will work for something similar will work for, oops, for the other two as well. Okay, so if I want to do something similar with a list, instead of making this a tup, I can make this a list, like this. So I'm going to say list plus equals, and this plus equals means add it to the end, in this case. Oops. In this particular case, we can add the string directly to the other string, right? So I can only add another string to a string. Cool. This ever wants to run? Okay, cool. So you can see I added the string hi onto the end of all of these, right? And the syntax does differ a little bit on the right-hand side, right? When you have a list and you're concatenating, you have to concatenate with another list. So notice with the list, I'm concatenating another list. With the tuple, I'm concatenating another tuple. With the string, I'm concatenating the string itself. And I put that space in there in this one just so that there would be a hello world and hi with a space in front of it. Otherwise, it would have just sandwiched up against world. You can extend this particular way of doing things to do a lot of manipulation of the types. So I could add, if I wanted to add something, let's say I wanted to add something to the beginning, one thing I could do, let's see if I can do this in a go, will be, oops, it'll be like this. Okay. That should do it. There we go. Nice and symmetrical. Okay. So what this is saying, if we look at these, just comment those out for now. So what this is saying is the new value of list is equal to this list with the element hi in it, plus the current value of list, right? So I take whatever the current value of list is, and then I add hi to that, right? And this is going to do the same thing, except it's going to add the elements onto the front instead of the back. All right, so you can see we have these elements on the front here. Why don't I just, let's do this. Oops. There we go. And yeah. So you can see this is going to add it all to the front. I could do the same thing up here, but I think we can, yeah, I think you can put that together. So this is kind of, I just wanted to showcase this solution. I'm realizing there's some more questions in here. Hopefully this is sort of a good starting place to the question that I was taking. But yeah, looking at least for lists, tuples, and strings, concatenation like this, and you can also add slicing and indexing as other tools for manipulating the types. So we can let's give one more example of this, and I'll show you how to use slicing as well to add things into the middle. So let's say I have I want to add this thing into the middle of these. Well, what I would do, oops, let's do this. Oops. See, there it is. So we want to add the elements to the middle. So I want I want to slice the list starting at 0, the collection, and I want to go up to, let's say, say I want to add this between 4 and 6, right? Like that's our original list and tuple, between 4 and 6. So that'll be index 0 and 1. So I want to start the list at 0 and slice from 0 up to 1. But remember, when the upper bound in a slice isn't included, so I actually have to go one more from that in order to include it. So I'll get that first part, and then I'll say plus the thing I want to add, which is high, and then the last part of the list, which will be, it'll start from where the other one left off. So plus the last part, I think it'll just be this. I always have to kind of guess at this every time, but that's okay. You can guess. So we should see 4, 6 high and then 2, 9. Yep, there we go. 4, 6 high and 2, 9. The same thing will work. I just have to make the type that I'm adding into a tuple. So that'll be for our tup. And let's say I want this string to say hello there world. So I'll say HELLO space. Okay, so that's index 5 plus 1. So I've got to do starting at index 6. And then, yeah, we'll start it off there. We'll say plus the string THERE plus string starting at 6. And I think I want to, well, let's try that real quick. Let's just see what that gives me. Oh, I didn't print it out. I think I'm going to have to do a little bit of an adjustment here, but that's not a big deal. Okay, right. So let's see. So I could either add a space after there, notice there and world are sandwiched together. So I think I also might be able to do 5 here. And that might pick up that space. I'm hoping that'll pick up that space. Yeah, so that picks up that space, right? So I can kind of fudge it in this case and do that. So hopefully this is a good example of the power of slicing and indexing. This is such a universally useful system, slicing like this. So, oops, and let me actually adjust this. Let's see. Let's see if we can copy this. And we wanted to add it in here. Oops. There we go. Okay, that's what those will do. Good. Let me save this. Cool, so that's, we didn't get to dictionaries with that, but I do want to move us forward. It's a good question. And yeah, I know that's not quite a comprehensive answer, but this is this is something that I'm a fan of in terms of like ease of problem solving. It's a universal system that if you put some time into understanding, that it'll allow you to manipulate lists, tuples, and strings. Sort of a fallback. Well, it's a fallback with lists, but it's what you need to do to manipulate tuples and strings for sure. So, okay, cool. Moving forward. Cool. And okay, to the original question asker regarding dictionaries, DM me about that if you want to go over that, and we can do that out of study hall. Piggybacking off of the previous question, how can you gracefully type check elements in a list or a string? I can think of a couple like contexts for this. Okay, so the way you can type check elements in a string is that all of the elements in a string are a string. I think what you might be getting at is like if you're trying to parse out, say, digits or numbers from a string, like if I had a string that says like I have 2 dogs, you might want to say like for character in this string, then we could say if character dot is digit dot is digit. So notice the digit is in reference to a character of a digit, right? It's in reference to the character. It's not a number. Digit is in this case a character that represents a number. A number is a numeric value, right? And that's a distinction that you might not make, or you might make differently in a different domain, but that's the distinction that we make in this particular context. So we'll say if the character is a digit, print ch, right? And maybe we can have let's have another string to accumulate the number. So let's call this num str for number string equals an empty string. And then we'll accumulate the number. Let's say it's a longer number, right? So let's say it's like 235, right? So we want to pull out the whole 235. That's a lot of dogs. Probably more dogs than any responsible dog owner should really own. But I don't know. I like dogs, but that's too many. But let's just say I have 235 dogs, and I want to do that. I want to parse out that number. So I'll say if the character is a digit, then we'll say we will say numster plus equals character. And then let's just print numster. Right, this is going to have some sort of other side effect behaviors, and like what if we have I have 235 dogs, 12 times a week. I don't know. We wanted to maybe do both of these. That might be a little bit, cause some extra work, but we'll just say we'll keep it simple for now. We can do that, right? So that's going to be 235. So great, I got a number. So presumably this is a number. Maybe I can like half the amount of dogs, or like let's say I have 1/3 of the amount of dogs. So I'll say I have this many dogs over 3. So I should be able to divide this number by 3, right? It's a digit after all. And unfortunately, you can look at this, right? So I wanted to point this out, right? This is going to get us the digits of the number, but this does not give us a number. This gets us a string of the number characters. So we have to, if we want to use this as a number, we have to cast this as an int or a float in order to do math with it and actually treat it like a number, right? So int or float, there are 2 functions, int and float, which will take in various other types. And if it can convert it to an int or a float, it'll convert it. So it can convert, if I have a string that's like 435, I can convert that to an int. I mean, those are digits. I can convert it, no problem. Int, no big deal. If I have like a character in there, like h435, this is actually going to give us an error. Right, we expect that maybe to print out 435. But Python's going to be like, hey, there's an H in there. I don't know what you mean by that. It's pretty literal. It's not going to make the assumption that you you or I might make of like, hey, convert this, convert the number part to a number and give me back the number part. It's going to be like, I don't know what you mean, right? So it's going to say value error, invalid literal for type int with base 10 H435. So that's all got to be number characters. Cool. All right. Woo. I'm having to keep up with all the questions. I enjoy this. I like all the activity. This is great. This is what I always hope study hall can be. I appreciate it, but I'm hustling, making me work, which I like. Please keep the questions coming. But okay, let's see here. Piggybacking. I hope that's helpful. We have some follow-ups on that. Okay, so we have a follow-up to this. It looks like says, thanks a lot. A mentor gave me a list of built-ins and isDigit was not on it. Otherwise, I was going to look into regex. I would say hold off on regex for now. It's powerful, and you know what? I don't know where you're at necessarily. Maybe you're ready for regex. It's rabbit hole though. So let's see. Built-in functions. When you say a mentor gave you a list of built-ins and isDigit wasn't on it, if I heard the term built-ins, I would think of built-in functions, not built-in methods. But there's a nice trick. Better than a list of built-ins, I will show you how to see all the methods for any type. Okay, so we're going to use a function called dir, and we need to print it out in order to see it. I'm just going to do this. Actually, we'll comment this out here. Okay. dir. So we'll say print dir for directory, and then just feed it any type. It can have literally anything in it. So if I want to see the directory for a string, I'll say dir string, dir string. If I want to see it for a list, I do a list. If I want to know it for an integer, I'll do an integer. Kind of can give a lot of output, so I'll just do one at a time here, and I'll let you do the others at your own discretion. But this is a great tool to help you explore what methods are available for each type, right? So it doesn't go into a lot of depth. It just tells you the names of the methods, which might not seem helpful because some of the names might not be obvious what they do, like zfill or translate. I mean, I know the word translate, but I don't necessarily know what it means by translate. Probably doesn't mean like translate into a different language. So you can look through these. The nice thing is, a lot of times the name just tells you what it does, right? So capitalize, well, that's kind of self-explanatory. So let's try it out. So if I print a string like hello there, that's not spelled correctly at all, and I call .capitalize on it, capitalize. Hopefully I spelled it correctly. Did I? Scapitalize. Hello there, you. I don't like, or let's say, I like a banana. They're good. Okay. Let's just capitalize this silly, ridiculous sentence and just see what happens. Or two sentences. Okay, cool. So it looks like it just capitalized the very first letter of it, and it didn't. I put in this period to see, maybe it's going to see the period and capitalize the next thing, which it doesn't do. So if I wanted to do that, I'd have to like find a way to also capitalize things after periods. But this is a nice, simple behavior. gives me a kind of a predictable template to work off of, and if I wanted to build in that functionality, I'd have to like find another way to do that, but that's fine. So that gives me an idea how capitalize works. And you can come through here and kind of look at all of these. You might see this one is alpha. And you might be like, oh, well, does that mean like an alphanumeric character? Which it does. And then you could go look that up. So let's say you're curious about is alpha. So here's what you do. Once you see one that piques your interest and you want to know a little more about it, well, you can play around with it. You can print it out, see if you can get it to do something that gives you an idea of what it does. And or you can use the help function. So I can say help. It's a function, takes parentheses, and then I'll just do the type, and then I'll call the method that I'm interested in, which is dot is alpha. Now, is alpha is a method. It does take parentheses afterwards. However, you don't want to call the function because that's going to give whatever the function returns to help. You just want to name the function. So it's kind of counterintuitive. You leave the parentheses off when you're passing it to help. So let's save that. And this will access the internal documentation built into Python, right? So this is the internal documentation for isAlpha. So it says isAlpha is a method of built-ins.string. So string is a built-in instance. Returns true if the string is alphabetic. Excuse me, I said alphanumeric. So this corrects me actually, which is good. So if it's alphabetic string. So what that means is if I say dot is alpha 4, well, 4 we already determined earlier. 4 is a digit. It's not alphabetic. It's a digit. So it's sort of well, it's not quite the full opposite because there are other characters that are neither alphabetic nor digits, right? Like a question mark or a period or an exclamation mark or the star character or something, right? Those are ASCII characters. They're valid Unicode characters for strings, but they're not. They're neither digits nor alphabet characters, right? So isAlpha will return true or false based on whether that string is an alpha character. Cool. Excuse me, I know I'm scratching my eye a lot. I think I just got like an eyelash in there or something, so apologies. I know it probably looks weird. Thanks for, well, shucks, now I'm bashful. I'm glad that helped. Good. Yeah, so just to wrap this one up, yeah, you have your list of built-in functions, and then now you've got a way of looking at the all the methods for any given type. And the takeaways here are print dir type, and then help on the method name, not the invocation, the name, right? If you get an error, just guess until you get your way there. But yeah, that's a way to get you there. Okay, let me see. Let's adjust this a little bit. Did I? Oops, okay. Is that gonna do it? Okay, good. All right, it looks like we have some other questions here. Okay. So we have a question, and I'm sorry about this. This was a follow-up to what I was doing earlier with the tuple, like why the comma after the tuple. I wrote it in, and I was like, I'm gonna explain that, and then I forgot. So let's say we have our tup. Let's look at this again. Tup. Now notice, if I'm explicitly stating a tuple, I don't like a list. I use square brackets. The only job of square brackets in Python, if Python sees square brackets, it's like, well, we're doing either we're declaring a list or we're using the square brackets to index to either index into an ordered collection like a list, a tuple, or a string, or we're slicing, which is sort of indexing with a range, right? It's indexing over several elements, right? So we're either doing a list or slicing or indexing. Those three tasks are only associated with like lists and objects that are similar to lists, such as tuples and strings. So there's kind of a narrow set of things that square brackets does. Parentheses, on the other hand, if you recall, like order of operations, by the way, my point in saying this is, if I'm making a tuple explicitly, I need to use parentheses. So, 4, 5, 2, 9, whatever. There's my tuple. But let's also recall, if I want to say, like, if I want to control the order of operations in some mathematical expression, like I want to say, like num, let's start with a num, and we'll say num to the, let's say I equals 2, but let's say I is in a for loop or something. Let's just do this. Okay, we'll go for broke here. For I in range, so I is going to be a number in a range from 0 to 9. I'm doing 10, so we'll get up to 9. And I want to print out the num to the power of whatever one more than the index is. So I don't want to raise num to the 0 to the 1 to the third or whatever, 1, 2, 3, etc. Excuse me. I don't want to start it at 0. I want to start it at 1. So I want to do I plus 1. Okay. So num to the I plus 1. The problem is, if I just write this like this, I mean, this is valid in the sense of Python knows how to execute this, although I'm not raising it to whatever the power of 1 more than I is. I'm raising it to I and then adding 1 to whatever that was. So this happens first and then this happens, right? So again, I need to use parentheses to control my order of operations. So let's look at these parentheses. I have parentheses delimiting a tuple, saying the tuple begins and ends here. I have parentheses in this range that says we have a function that has these inputs, and the way we know where the input starts and where it ends is with parentheses. And then I have parentheses used to control the order of operations in a mathematical function, right? So what we went over with square brackets do things. When Python sees a square bracket, it's either declaring a list or doing something with an ordered collection like a list. Kind of simple. Whereas parentheses have at least these three, and I may be even able to think of a couple more other uses for parentheses in Python. So when some piece of syntax, something like this, has multiple jobs, we call that overloaded. So in programming parlance, if you want to, okay, I just used that word, whatever, I'm going to own it. In programming vernacular, we would say that parentheses in Python are overloaded, meaning they have multiple jobs. Square brackets are also technically overloaded. They do have multiple jobs, although the scope of what they do is less divergent than with parentheses. So why am I saying all this? If I want to add something to a tuple, let's say I just want to add this to the tuple, whatever this is. This will be kind of convenient. I want to use my tuple as an accumulator. Okay, so if I say tup equals tup plus this, right? This is going to say whatever the current value of tup is, which has these things, plus this. Well, if this were a list, I could put square brackets around it, and then I'm concatenating two lists, because square brackets only mean I have a list. This would be a list with a single element in it. If I have a tuple, on the other hand, and I put parentheses around it, what does that look like? This looks to Python, it can't distinguish this as being a tuple from this being an order of operations, inner to outer mathematical expression or expression like evaluation order control, right? So it can't tell that what I meant was add this tuple to this other tuple. It doesn't see this as a tuple. So the way that it knows something is a tuple is with the comma. So it's kind of a circuitous explanation, but that's the whole foundation of it, right? So since parentheses have multiple jobs, Python needs to be able to distinguish what is just a set of parentheses with something to be evaluated within it versus what is a set of parentheses that specifically delimits the beginning and the end of a tuple, right? So in order to tell it that it's a tuple, we need to put a comma in there. And you might think, oh, okay, so it has to have more than one element, right? Like you might think, okay, well, this is the first element in that tuple, and then the next element is like none or an empty element. That's not the case. This is a tuple with one thing in it, and that is how you write it, right? So if I wanted to write a tuple with one object in it, it'd be like this. So if I only want 2 to be the only member of the tuple, I can write it like this with 2. If I write no comma, it's going to be like, well, these are parentheses, and I need to evaluate what's in it. Well, 2 evaluates to 2, so it evaluates the parentheses as 2. 2 just comes out of there. So anyways, all right. If you, just to wrap this up, if you want to declare a tuple with nothing in it, you don't need parentheses. You don't need a comma. So a tuple with nothing in it is just parentheses. A tuple with one thing in it has one comma. A tuple with 2 things in it has 1 comma as well. So it's a little funky when tuples only have one thing in them, but that's how it is, and that's how it has to be so that Python can distinguish what you mean when you're trying to do a one-part tuple versus evaluation group. Cool. Okay. Good. We also have a question about, does tup.append work as well? Remember when I talked about dir? So that's not a dumb question. That's a really good question. The answer is no, but it's still a good question. So let's look at the dir for lists, dir, dir instead of w, dir list, and then let's do the same thing. Oops, let's do the same thing for tuples. I think that'll work. Yeah, so let's look at list first. Okay, and I'm just gonna, so here real quick, I forgot to mention this, there's all these dunder methods here. You can look into these, what these are. I would say for our purposes, for the scope of premium prep, there's one class where I cover these a little bit near the end, but I only cover them really because people ask about them. These are, I know it's sort of a little bit of an unsatisfying thing to say, but like, you don't need to worry about these for now. You can ignore them for now. If you want to go look into dunder methods, call them dunder because they begin and end with double underscores. If you want to go look at dunder methods, you can just go look that up on your own time, but I'm not going to dive into these. So for starting off, you can just ignore those for now. Go to the normally named methods. Append, well, there's our append. It's the first one because it's alphabetically the first. Clear does what you think it's going to do. It's going to just empty out the list. Copy makes a different list with the same contents, so you sort of duplicate the list. Count gives you the count of some element in the list. Extend is similar to append, but you can pass it another list of objects and it will add all of those instead of just one. Index. Index gives you the index of the element passed to it, if that element's in the list. Insert is like append, except it allows you to add something rather than at the end, at the beginning, or anywhere in the middle. Pop, remove, reverse, sort. Okay, I don't want to necessarily go over all these in depth, but these are your list methods. Let's just copy these real quick and paste them in for list. So dir of list is going to be that. And then let's do dir of tuple. For some reason I think that's not going to work. I think I'm going to actually need to spell this out. Oh, that does work. So dir of parentheses. I got kind of a lot of parentheses going on there, but this is going to work. So let's look at the normally named methods without the dunders. Well, we have count and index, right? And if you look, lists also have count and index, but they also have all these other methods. And this actually helps you if you're having a hard time understanding the difference between, if you're looking at lists and tuples and you're like, well, they're both collections of arbitrary objects, but for some reason people are saying lists are more powerful or tuples are less powerful. I wouldn't say that. I wouldn't say like one is better than the other. They have their own applications. I mean, for now, like you can probably just use lists for whatever you need to use them for. But if you're having a hard time understanding the difference between mutability versus immutability, this is actually a really good example. This is a way of learning by example. So let's find them. All of the methods that lists have that tuples do not have mutate the list. All of them, right? So let's see, we've got count here. Let's get rid of that one. And we've got index here. So there's count and index. So let's sort of set these aside. Let's just indent those. And then we've got all the other mutable methods right here. And let's go there. Okay. So these are now out of alphabetical order, but they're sort of grouped by mutable versus immutable. And let's just do this. Okay, there we go. So append adds something to the end, clear empties it out, copy makes a different copy, sort of duplicates the list. Extend acts a lot like append, changes the value. Insert changes the value. It's like append or extend, except it adds something to the beginning or the middle. Pop removes something at an index and returns the thing it removed, so you can capture it and do something with it. Remove removes something, so these both change the value. Reverse and sort change the order of the items. Reverse just reverses it, just puts it in reverse. Puts it in the opposite order that it was in. So if it's 1, 2, 3 and you call reverse on it, it'll be 3, 2, 1. Sort is going to sort it. So if you have 3, 1, 2, you're going to end up with 1, 2, 3, right? So all of these change the value of the list in some way. So this is if tuples had an append, they would just be lists. They would essentially be exactly like lists because they would be able to be mutated. Yeah. So yeah, hopefully that helps. Oops. Okay, cool. I'm not seeing any other questions. We're kind of getting close. Well, we got a late start today, so I'm going to continue things. Kind of feels like a hard jolt to go from like beginning stuff to like intermediate stuff back to beginning stuff. But I'm not seeing any questions, so I'm gonna go back to where we started today. Okay, so hopefully if you're starting off in the new premium prep, if you're new to programming, that was sort of a little window into what you'll be getting into in a week or so. You'll be kind of getting into those particular weeds. But for now, and hopefully it gives you some idea of data types. I'm gonna kind of hope that that's the case. But looking at these ints and floats, yeah, hopefully that gives you some context of where everything's headed. So yeah. So as we saw, feels so awkward to just like switch gears back into this, but that's okay. So as we saw, we can use these mathematical operators to perform, well, these four, right? To perform operations on numbers that we would expect. So these are going to behave like we expect. I did want to touch on, there are two other division operators. Oops. Two other division operators, excuse me. Or operators that are related to division, right? So we have single slash division, which is regular division. So if I divide 4 by 5, that's going to take these two integers, and that's going to give me a float in return because it can't complete that operation without, giving me a decimal number. If I use double slash division, this is kind of hard to see with these particular numbers. If let's say I divide 20 by 5, or let's say 20 by 3, and let's do it with this too. 20 divided by 3. Okay, so 6.66666 repeating versus 6, right? So this single slash division is going to say, well, how many times exactly, or as close to exact as possible. This actually is a, I'm blocking on the term, but this is a precision error, right? Where Python can't calculate this number, right? So it just repeats it over and over and over as far out as it can go before it has to stop, because there's limits to, the precision of the CPU. So it calculates it as best it can, and we're going to get as close to an exact answer of 20 divided by 3 as we can get. So this is going to tell you how many times, when you use double slash, it's going to tell you how many times 3 goes into 20. So if I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that last time was 7, and that went over 20, so I can't do that. So 3 goes into 20 6 times without going over 20, right? Cool. So if you want to know how many times something goes in exactly in terms of a whole number, you can use what we call this floor division, or you can just think about it as double slash division or integer division. If you want to know what the remainder is of a floor division operation, you use the modulo operator. Now, this is what you're probably familiar with calling a percentage. If you see this symbol in Python and almost any other programming language, every other programming language that I know uses this symbol to mean modulo. You can think about modulo as the remainder operator. So that's the simple way of explaining it. There's a whole thing about why it's called modulo and modulus, modular arithmetic, whatever. But if you want a simple explanation, you can in your mind you can call it the remainder operator. In the course of class, I will be calling it the modulo operator. Often we just shorten it to mod. So the way we would say this is 20 mod 3. And if that's confusing, just translate that as 20 over 3 remainder. What's the remainder of 20 over 3, right? So this should have a remainder of 2. So I think about these two as sort of like if you learn to do long division by hand the way I did when I was in grade school, you'd get these two numbers rather than a super precise number, right? So you'd get how many times 3 goes into 20, and you'd get the remainder of that. So cool. Just because I think this needs emphasis, you might look at this and go, okay, well here are the regular operators that I'm familiar with. And, excuse me, oof, got the kind of hiccups. So here are the regular operators that you're familiar with, and then here's some weird division operators. You will use modulo. This is not something that's like, oh, okay, well, I guess, if I end up needing this for something weird, I guess it's there. Well, it's easy to sort of look at this and forget it if it's not landing right away. Why that's useful? I guarantee you will use modulo. It's surprisingly useful. I remember when I was first learning programming, I kind of did this. I've also seen people do this, and we'll give them a modulo problem, and it'll be sort of a, what do I do? How do I handle this? Because it's easy to forget this if you don't like put some emphasis on it and say like, okay, I need to remember that this exists and that it's useful and that I need to use it. So yeah, don't forget about modulo. It's useful. Okay. So we talked about integers. We just sort of touched on floating point numbers. More commonly, they're called decimal numbers. So yeah. In programming languages, we call them floating point numbers. The Boolean type. Let's talk about the Boolean type. So Booleans are simple. A Boolean value has one of two states. A Boolean can either be true or it can be false. These are the only two valid values for a Boolean. True or false. So it's simple. And we can use this to do some pretty cool things, because there are operators that help us do like Boolean logic, right? So a lot of things in Python will evaluate to true or false, right? So if you recall when I did the string, like hello.isDigit, often if you see a method or something that starts with is, well, it's probably going to return true or false. Like it's either true that hello is a digit or it's false. And you can think, is hello a digit, true or false? False, like hello is not a digit, right? So if we print this off, if we print that off, we're going to get false. Hello.isDigit is false. So there's a lot of things like that. There are several operators. Let's say I have two numbers. A is 4, oops, and B is 3. Let's print A greater than B. So A greater than B, well, we have this greater than operator. So if you think about greater than, right, something can either be greater than or not greater than. It can also be equal to, but if it's equal to, then it's not greater than, right? It's equal. So A greater than B, you think about that, is that going to be true or false? So obviously that'll be true because A is 4 and B is 3. A greater than B, 4 greater than 3. Didn't mean for that to rhyme, I promise. Yeah, so 4 is greater than 3, so that's true, right? So we can say A less than B, and that's going to be false. So we have these operators that compare the two values. Sometimes these are called Boolean operators or comparison operators. We can also check if they're equal. If I want to see if A is equal to B, notice I have to use two equal signs. And the reason for that is a single equal sign is already taken for this assignment, right? When I say A equals 4, a lot of times we'll read this as gets, right? So A gets the value 4. So the value 4 is assigned to the name A, and the value 3 is assigned to the name B, right? So I just did this without qualifying that we were talking about variables, but these are examples of variables, right? So we can check if something is greater than, less than, equal to. We can also check. We can also include equality in these, so we can say greater than or equal. Oops, equal or less than or equal. These are also valid. We can also check if something's not equal, and the not equal operator is going to be exclamation point equals, right? Okay. There we go. Actually, let's do this. It's not going to let me do it. Let's see. Let me see. I might be able to fudge it. Oh, no, it's not going to let me. Okay. I'll just have to write it out. True. False. False. True. True. False. There we go. Cool. All right. So that's a brief overview of some of the basic types in Python. These might seem basic, but they are. The thing here is worth remembering and understanding, but not getting too stuck on. But yeah, hopefully that was helpful. Looks like we got another question here. It says, I'm a beginner. That's cool that you're going through back to basics. Oh, cool. I'm glad that that's helpful. Yeah, definitely feel free to DM me anytime if you have any questions. I'm kind of busy at the moment. So we're kind of winding down after our big push to get our interview deadlines met. Oops. I want that to be a comment. So it may take me a little while to respond over Slack, but yeah, feel free. Anybody wants to reach out, ask questions if you need help with anything, especially on Learn, I'm available for that. So yeah, this is a good place to wrap up here. Apologies again for starting late today. Yeah, like I said, it's been a little hectic, sort of just wrapping all that up, but things are definitely cooling off now. And hopefully next time I won't have problems with OBS recognizing my text editor and presenting. But yeah, I'll do my best to get things started on time for Friday and in the future. Hope everybody enjoyed and found this useful. No, we didn't necessarily go through the basic stuff too much, but I feel like we took some good questions. And if you are just starting, feel free to bring whatever questions or comments that you might have, and we can go over those in study hall. If you're in premium prep, then I'll see you in about an hour and a half. Cool. We can wrap up there, but yeah, it's been fun. Y'all have a good rest of your evening. Bye-bye.